Hey everyone, so we're looking at chapter 6 today and specifically section 6.7. So as you can see, these are going to be topics in analytic geometry and we are focusing on polar coordinates. So obviously, every kind of graphing that we have done so far has been in the rectangular coordinate system where we are given the points x and y, right? Where basically x and y will represent the directed distances from the coordinate axis. So what they're basically saying is basically when you are graphing these points x comma y on a rectangular coordinate plane, it basically tells you how far you need to go from the x-axis, either above or below the x-axis, which of course gives you the y value, and then how far you need to go from the y value, either the positive or the negative side, which is your x coordinate. So basically they're saying it's the directed distance from those two axes when you are graphing these points x comma y. So here, like I said, we will be talking about the polar coordinates and we'll be talking about the polar coordinate system. Okay, so they're saying to form the polar coordinate system in the plane, we have a fixed point O, which is what we call as the pole, or you can think of that as the origin. Pole is more commonly used, so the fixed point O is called the pole, and you construct from that point O an initial ray, which is called the polar axis. You can kind of think of this as being your horizontal axis, so you can see that right here in the figure. So you start from point O and you draw an initial ray called the polar axis, and then you will have point P, which has the polar coordinates r comma theta. Okay, so the polar coordinates will be r comma theta, and r is basically defined as this distance from that origin or the pole O to that point P. So we call it a directed distance from O to P, and of course your theta is going to be the directed angle which goes counterclockwise from the polar axis to this segment OP. Okay, so your theta is the directed angle counterclockwise from the polar axis to the segment which is the line segment OP. So let's talk about how we can actually plot these points. So first you should look at our graph over here. So we've got our polar axis in this case, as you can see, and then we've got our angles going from 0, pi halves, pi, and 3 pi halves. Okay, and you will see the concentric circles that we have follows along with the distance of how far away we are from that pole of or the origin. So you've got your distance of 1, 2, 3, and then depending on your graph, you can draw as many concentric circles as you need. So in the first part, they're asking us to plot the point 2, comma pi over 3. So remember, 2 is the r value, and pi over 3 is our theta. So 2 tells us the directed distance from the pole to that point P, and pi over 3 will tell us the directed angle. What is that angle going to be from our polar axis? So pi over 3, of course, is our 60-degree angle, which means this angle from the polar axis has to be 60 degrees, or pi over 3, and then this distance has got to be 2, which is going to be our 2 units from the pole. Now you draw a little point at that, but you will see we extend that line going forward, but right at the point 2 and pi over 3, of course, we'll just mark it like I said, with a little point over here. Okay, so basically they are saying the point 2 comma pi over 3 lies 2 units from the pole on the terminal side of our angle, and that angle measurement is going to be pi over 3. Now looking at our part B, we are given r as 3 and theta as negative pi over 6. So negative pi over 6, of course, tells us we will be going in the clockwise direction, and Negative pi over 6, of course, is going to be negative 30 degrees. So here, starting from our polar axis, you will be going in the clockwise direction to get your negative pi over 6, or like I said, your negative 30 degrees. And then our directed distance is going to be number 3. So that means you are going to start from the pole and you're going to go out to that third concentric circle to get your point 3 in the directed direction angle of negative pi over 6. Okay, for part C, they are asking us to find 3 comma 11 pi over 6. So again, our directed distance is 3. Our directed angle is 11 pi over 6. Now 11 pi over 6 is going in the counterclockwise direction, but basically if you were to go in the clockwise direction, this would be equal to negative pi over 6 or negative 30 degrees. So if you will notice, this point 3 comma 11 pi over 6 is the same as our point 3 negative pi over 6, which you saw in part B. So like it says, 3 comma 11 pi over 6 coincides with the point 3 negative pi over 6. So that is just going in the clockwise direction for part B. Oh, that should be clockwise. And then of course with the 11 pi over 6, we are looking at counterclockwise. But you're basically landing at the same point. Okay? Alright, so let's take a look at our examples here. Again, we are trying to plot 3 of these given points in our polar coordinates. So let's take a look at this. Alright, here we go. So you can see I've already created my polar coordinate system over here. So let's start with the first one. So remember, the first coordinate is your directed distance. The second coordinate is the directed angle. So angle pi over 4, you should know, is basically your 45 degree angle, right? So this is the same as 45 degrees. And so that's of course going to be exactly halfway between 0 and pi halves. And I'm going to try and do my best to kind of do this in the middle. And then we are looking at a directed distance of 3, which means that would be at the third concentric circle. And this point is going to represent our 3 pi over 4. So this angle here is our theta of pi over 4, and then our directed distance is 3 units. Okay, so I hope this kind of makes sense, and you will again see we have our angles going from 0, pi halves, pi, 3 pi half, just like we do on a unit circle, and then we draw these concentric circles depending on our distance from the pole. Okay, and remember the pole is the origin. All right, let's look at our second example over here. So again, my R value is 2. Theta is negative pi over 3. Now remember, pi over 3 is 60 degrees, so negative pi over 3 will be negative 60 degrees. So let's see, where does that angle fall? We are talking about 60 degrees. So let me see, negative 60, probably somewhere. And do your best to be in the right angle. It's not going to be accurate since we're not using a protractor here, but of course, try and get your best estimate where this should be. And this is a distance of r equals 2, which means we are going to be at the second concentric circle. So this is going to be our point 2 comma negative pi over 3. And so this angle here is our theta, which is negative pi over 3, and then this distance from the pool is going to be a distance of 2 units. Okay? Alrighty, so that's our second part. Now let's see, for part C, we are given 2 comma 5 pi over 3. So again, R is 2 and theta is 5 pi over 3. So again, if you use your unit circle, you will see 5 pi over 3 corresponds to your 300 degrees, or basically if you were to do this in clockwise direction, you would actually be at negative 60 degrees. So when I go ahead and draw this point, let me see if I can get this somewhat here. It's not a very straight line, but you kind of get the idea. And so we are talking about 5 pi over 3, which means you are starting from your initial side and going this way, which is going to be your theta equals 5 pi over 3. And then that's r is a distance of 2. So again, at the second concentric circle, so this will be 2 comma 5 pi over 3. And again, this directed distance is going to be r equals 2. And just like you saw in our example 1, you should notice that our point 2 comma 5 pi over 3 also coincides with the point from part B, which is our point 2 comma negative pi over 3, because that angle, negative pi over 3 and 5 pi over 3, are basically the same angle, just depending on which direction you come from. Okay, so those 2 points are going to coincide from parts B and C. But as you can see, it's really not that bad or that hard when you are trying to draw these polar coordinates. As long as you have the polar coordinate system, plotting these points is not going to be that difficult. Okay, alrighty, so now let's go back over here. So we are saying in rectangular coordinates, each point x and y has a unique representation, right? Because if you have different values for x and y, it's only going to direct you to one point. So basically the idea is, if you have a point 2, negative 3, it's not going to be the same as the point 2, positive 3, right? Because each of these points will give you a unique representation. That is what they're talking about. However, when it comes to polar coordinates, that is not true. So, because remember how with our angles over here, you can have coterminal angles, right? Which have the same initial and terminal side, but just depending on how many concentric, not concentric, but how many circles you make around it, you can come up with different measurements for that same angle. So your r comma theta is actually going to be the same point as r comma theta plus 2 pi, because when you do plus 2 pi, remember you're basically coming a full circle and coming back to that same point. So that's why, since your angle measurement can keep changing, for the same point, you can actually have multiple different representations. You can write it in many different ways. So that's kind of what they're talking about here, that since these two coordinates here would have the same point, you do not have a unique representation for your polar coordinates. They are saying another way to obtain multiple representations of a point is to use negative values for r. So just by changing the angle, you can get multiple representations, but also you can use a negative value for r. And they are saying because r is a directed distance, then r comma theta and negative r and theta plus pi will actually also end up giving you the same point. So just like r and theta plus 2 pi can give you the same point for r comma theta, in that same way for r comma theta, you can get another representation by taking a negative value on the r and adding a pi to your angle measurement. So we are saying in general, the point r comma theta can be represented by either adding or subtracting multiples of 2 pi from your angle, or for the same point r comma theta, you can take negative value on your r and then add or subtract basically multiples of pi from your angle theta. So you can add 1 pi, 3 pi, 5 pi, any of those values, because we are doing 2n plus 1 over here, so that will always give you an odd number. So you can add or subtract, like I said, multiples of pi with a negative r value, or you can add and subtract multiples of 2 pi from your angle with a positive r value, and it will give you the same representation for the same point. Okay, and of course n will be any integer. They are saying, moreover, the pole, which is your origin, is represented by the point 0 comma theta, because the idea is, and just let me show you this on the grid. So if we are right here at the origin, your distance is going to be 0, so that's why your r is 0, and it doesn't matter what angle you are going to be at, because theta can be any angle, but since your distance is 0, you are not going anywhere away from the origin, right? You're always going to stay at the origin. So you can use this representation 0 comma pi for the pole. Alrighty, so let's go ahead and see how we can come up with these multiple representations over here. So they're asking us to plot the point 3 comma negative 3 pi over 4 and then find 3 additional polar representations. And basically here we want our theta to stay between negative 2 pi to positive 2 pi. So basically you can go one whole circle in the counterclockwise direction, and you can go one whole circle in the clockwise direction, and those would be the angles you are allowed to use. So of course you can see we have a distance of 3, which is our r value, and this is a negative 3 pi over 4. So negative 3 pi over 4 is basically going to be negative 135 degrees. So that's where you can see we have our terminal side over here. So this angle here is making our theta of negative 3 pi over 4. And then they're telling us it's a distance of 3. So you are at that third concentric circle. Now for the other representations, you can see we are keeping our distance as 3. And then to our angle, negative 3 pi over 4, we're adding 2 pi, which ends up giving us 3 comma 5 pi over 4. 5 pi over 4 is still less than 2 pi, so we can use that angle measurement. Or, like I said, you can add or subtract multiples of just pi. So here you can see we are, and this is of course when you make your r a negative value. So by making our r a negative value, we are subtracting pi from negative 3 pi over 4, which gives us negative 7 pi over 4, which is still less than, it's greater than negative 2 pi, so we are still okay with that angle. Or instead of subtracting pi, you can add pi to your angle, keep that negative on the r value, and you end up getting negative 3 pi over 4, which is of course again going to stay within this range of our theta. So that is also okay to use, and all of these end up at the same point as you are seeing the graphical representation over here. Okay, so just a different way of writing the same point, either by using multiples of 2 pi on our angle, or negating the r value, the first coordinate, and then adding or subtracting multiples of pi from it. So let's see what we can do here with our example. So again, they're asking us to plot negative 1 comma 3 pi over 4 and then find 3 additional polar representations. Again, they want us to keep our angle between negative 2 pi and positive 2 pi. So the first thing we're actually going to need to do here is to be able to plot this, we will go ahead and convert this into our negative r, and this is theta plus pi. Okay, so our original number is negative 1, 3 pi over 4. So I'm going to do negative of negative 1, right? Because this is saying negative on the r value. So that's our negative on the r value. And then our theta is 3 pi over 4. And I am adding pi to that. So that will end up giving me negative times negative will make this a positive 1. And then when you add 3 pi over 4 with pi, that will end up giving us 7 pi over 4. Okay, so now we can go ahead and graph this on our polar coordinate. So 7 pi over 4, if it helps, is going to be 315 degrees. Or basically you can think of that as being your negative 45 degrees. So that would be halfway between our quadrant 4 over here. So about a 45-degree angle from any of those axes. Okay, and then of course you are at a distance of 1 because our r value is 1. So you are going to be at that first concentric circle. So this will actually give you negative 1, 3 pi over 4, or you can think of this as negative 1, 3 pi over 4 equals positive 1, 7 pi over 4. Okay, so just for using this in our graphing method, we have actually gone ahead and gotten our first representation for our original angle. So now we just need to find 2 more representations. So in this case, we did negative r theta plus pi. So how about we now try negative r theta minus pi. So instead of adding pi, we are subtracting pi. So again, you will be doing negative on negative 1. Theta is 3 pi over 4, and we are subtracting pi for it. So negative times negative will make that a positive 1. 3 pi over 4 minus pi will end up actually giving us negative pi over 4. So this will be our second representation for this point. So you can write this as equal to positive 1 and negative pi over 4. And again, you should be verify that as the same point over here on our polar coordinate. So this is our second representation. Now we need to find one more. So how about this time we keep our r value the same, but instead of adding pi, we now add or subtract multiples of 2 pi. So how about we start by adding 2 pi. So we're keeping the r value as it is, and we are doing 3 pi over 4 plus 2 pi. And that will end up giving us negative 1. And let's see, 3 pi over 4 plus 2 pi will end up giving us 11 pi over 4. Okay, but here's the problem. At 11 pi over 4, you are actually looking at this angle being greater than 2 pi. Okay, and if you just want to verify, plug this in your calculator and find the degree equivalent of it, so you know which angle you are going to be at, and you will see that this is going to be greater than 2 pi. Okay, so that should basically give you 495 degrees for that 11 pi over 4. So you can see it's greater than 360. So we actually cannot use this representation because it is outside our boundaries. So cannot use this representation this theta is outside the bounds of okay. So instead of this, what we can do is, how about we take our r and theta, and instead of adding 2 pi, how about we subtract 2 pi, and let's see what happens. So negative 1, and this time we have 3 pi over 4 minus 2 pi. So let's see, that will end up giving us 3 minus 8, which will of course give us negative 5 pi over 4, and negative 5 pi over 4 is going to be within our bounds, so we don't have to worry about that being outside our bounds. So we can actually use this as our third representation, and that means we can say this is equal to negative 1 and negative 5 pi over 4. Okay, so this was our third representation. This was our second representation, and this one was our first. So there we have our 3 representations that they were asking us to find, and of course we've got our plot for that point as well. So that's what they wanted us to do here on example 2. Alrighty, now let's talk about our coordinate conversion. So they are saying to establish the relationship between polar and rectangular coordinates, we need to let the polar axis coincide with the positive x-axis. The pole will coincide with the origin. So you can kind of see here, our polar axis is also now our positive x-axis, and then our pole will be our origin. And then because of this, we can say our x and y lies on the circle of radius r. So what they are saying, of course, this is our origin at the pole, right? At 0, 0. This distance here from the pole to the point x, y, or r theta is distance r. So you can think of that as being your radius. And then this point, you can think of that as being on the circumference of a circle, right? If that circle was going around, which of course this is really bad, but if that was a circle using this distance r as its radius, then you could say point xy basically falls on that circle, right? It's going to be a point on that circle. So using this idea, we can use the formula that r square equals x square plus y square, right? You are just using the circle equation, x square plus y square equals r square. And of course, you can see that comes from the influence of our Pythagorean theorem. If you think of this forming our little right triangle here with the distance x, the distance y, and the distance r, using our Pythagorean theorem, we can also come up with the equation of our circle. So they are using that formula basically to come up with this equation, r square equals x square plus y square. And they are saying, moreover, if that r is a positive value, then we can use these trigonometric functions that we basically saw in chapter 1, right? Tangent theta. So if this is our angle theta over here, then tangent would be opposite over adjacent. So that's y over x. Cosine would be adjacent over hypotenuse. So that's x over r. And sine, of course, would be opposite over hypotenuse, which is y over r. So they're basically just using those same functions that we had used in chapter 1 to kind of come up with these definitions for tangent, theta, cosine theta, and sine of theta. And this will actually help us kind of talk about that relationship between the polar coordinates and the rectangular coordinates, okay? And basically you can show that it will be the same relationships even if our r value was a negative number. So this is what you need to remember when we are wanting to make our conversion from polar to rectangular or from rectangular to polar coordinates. So polar to rectangular, our x is defined as r times cosine theta, y is defined as r times sine theta, and then if you are going from rectangular to polar, then you would have to use the relationship tangent theta equals y over x, and r square equals x square plus y square. Okay, and these should look familiar to you from our chapter 4 discussion. So we had looked at these discussions when we were doing our complex numbers, which we were converting from the complex form to the trigonometric form, or from the trigonometric form to the complex form. So we're basically bringing that same idea here, because your polar coordinates actually do come from your complex form. So this is all interconnected with each other. Okay, so let's take a look at our example here. We are given our polar coordinates over here. Square root of 3 is the r value, and of course our angle theta is pi over 6. So we want to convert this to rectangular coordinates. So this is where we use the definition x equals r times cosine theta, y equals r times sine theta. So there we go. So that's going to be r is square root of 3 cosine of pi over 6. R is again square root of 3 times sine of pi over 6. So just use your unit circle for pi over 6, and you can see your cosine and sine values over here. So that's where we're getting the square root of 3 over 2 and 1/2 from. Multiply that with the r value of square root of 3. Simplify them, and you end up getting x equals 3/2, y equals square root of 3. And that's how we went from polar to rectangular coordinates. And when you look at their graph, of course they are going to be the exact same point on our graph as well. Okay, so it's not too bad as long as you remember that relationship between x and y and the r cosine theta, r sine theta respectively. Okay, so let's go ahead and take a look at our example over here. We are given 2 comma pi, which is in polar coordinates, and they're asking us to convert this into rectangular coordinates. So let's start with this guy. So remember, r value is 2, theta is pi. So if I wanted to graph this, pi of course is going to be at the 180 mark, right? And we are going a distance of 2. So from the pole or the origin, you are going 2 units out in the direction of angle pi. So it's going to be this point right over here. Now we have to see what this is going to be in our rectangular coordinates. So this is where we bring in the relationship x equals r times cosine theta, and y equals r times sine theta. So r is 2, and then you're multiplying that with cosine of pi. Let's give a little space over here. And same thing with y value, we will do 2 times sine of pi. So let me just show you on our unit circle. Here's our angle pi at 180 degrees. You can see cosine is -1 and sine is 0 for the angle pi. So this will end up becoming 2 times cosine of pi is -1, which will end up giving you -2. So this is our x value. And then sine of pi is going to be 0, so that's going to be 2 times 0, which will end up becoming 0. So that's your y value. So we've got x equals -2, y equals 0. So this ends up giving us our rectangular coordinates. And our rectangular coordinates x comma y is going to be -2 comma 0. And so if you think about this, if we coincide this with our, let's say we want to say this is our x-axis and this is our y-axis, and if this is positive 1, 2, 3, let's say this is -1, -2, negative 3. So of course our negative 2, 0 would again fall at the same point over here, and you would have negative 2, 0 in your polar coordinates. Sorry, rectangular coordinates, which coincide where your polar coordinates are. So they end up falling right on top of each other, right? So 2 comma pi will end up becoming negative 2, 0 in the rectangular coordinates over here. Okay, now let's go the other direction. You are given the rectangular coordinates and they're asking us to convert this into polar coordinates. So remember, when you're going from rectangular to polar, we need to use tangent of theta equals y over x and r square equals x squared plus y squared. So here's our x and y value. So y is positive 1, x is negative 1, and you end up getting tangent of theta equals negative 1. Now if you look at your unit circle, tangent of theta is negative 1 right here at, looks like the first point will be 3 pi over 4. Okay, so there we go. So you can get 3 pi over 4 by looking at your unit circle, or basically, since this is a second quadrant point, we know negative 1, 1 lies in our second quadrant. You can also use this definition, which you had seen in chapter 4, that theta is going to be pi plus arctangent of negative 1, and that will also end up giving you 3 pi over 4. So whichever method works for you, go ahead and use that. Okay, so we have found our theta. So this is our theta, which is 3 pi over 4. Now we just need to find the r value, because remember, your polar coordinates are r comma theta, and since we know r square equals x square plus y square, you can go ahead and take a square root on both sides, and you're getting r equals square root of x square plus y square. And in this one, we are going to use the positive value for r, since our angle lies in the same quadrant as the point xy. Okay, so x was negative 1, so negative 1 squared, y is positive 1, so positive 1 squared under a square root, and that gives you a distance of square root of 2. So the polar coordinate comes out to be square root of 2 comma 3 pi over 4, and you will see it basically coincides at that same point, negative 1, 1. So that's your polar coordinate derived from the rectangular coordinate. Okay? Alright, so let's see. We are given the rectangular coordinate 0, 2 and asked to find its polar coordinates. So let's go over here. Again, think of this as our x-axis. Think of this as our y-axis. So when you are plotting the point 0, 2, this would of course be positive 1, positive 2, and positive 3 on our y value. So 0, 2 would be this point right over here, and we want to know what its polar coordinates are. So we are given x comma y as 0 comma 2, and of course this lies directly on the y-axis. I'm not sure what happened there. Okay, so let's start by finding our theta. So that's going to be tangent of theta equals y over x. Our y value is 2, x is 0. So 2 divided by 0, remember division by 0 is undefined. So you have to think, where is tangent theta undefined at which point? So again, you can go and look at your unit circle. Remember, anytime you end up dividing by 0, you are going to have an undefined value for tangent. So that happens at pi over 2, because we end up dividing 1 over 0, which is undefined. It also happens at 3 pi over 2, but of course we're interested in the first angle you come across, which is pi halves. So that means our theta is going to be pi halves. Okay, so now that we have the theta, we just need to calculate the r value. So remember, that's r square equals x square plus y square. And again, since our angle theta lies on the same axis as our point xy, that means we can let our r value be positive. So we can say r is greater than 0. So when you take a square root on both sides, you just have to worry about the positive r value, and you don't have to worry about the negative r. So we are basically discarding the negative answer, okay? So again, our x squared is going to be 0 squared. Our y squared is going to be 2 squared. So this will again end up giving you 0 squared plus 2 squared will end up giving us square root of 4. And of course, square root of 4 will end up giving us the r value of 2. So once you have your r and theta, of course, we can go ahead and get our polar coordinates. So our polar coordinates are going to be r comma theta, which is going to be 2 comma pi half. So you are now going in the direction of the angle pi halves, which is of course 90 degrees, and you have a distance of 2. So here's our pi half angle on the positive y-axis, and going a distance of 2, you will see we are coinciding with the same point from our polar coordinates, which is 0, 2, and now this guy is 2 pi halves, okay? So this was going in the opposite direction from rectangular to polar coordinates. Alrighty, so this was just going from one point to the other in different coordinates, but what about if we wanted to convert our equations? So they are saying to convert a rectangular equation to the polar form, we will need to replace our x with r cosine theta, replace our y with r sine theta, just like we did with the points. That's the same conversion we are doing here. So they're saying, let's say we have this rectangular equation, which is y equals x squared. So for y, we make the substitution with r sine theta. For x squared, we make the substitution with r cosine theta, the whole quantity squared. And then basically you are trying to get the r by itself and move everything else to the other side. And once you clean that equation up, you end up getting r equals secant theta times tangent theta. So you can see we no longer have any x or y variables in here. This equation is now in terms of r and trigonometric functions with the angle theta, right? So this is converting it from rectangular to polar form. Now they are saying converting a polar equation to a rectangular form requires considerable ingenuity. And so this is where we are going to be looking at how we can convert from polar to rectangular conversions, and see how that can help us also to come up with the sketch of the graphs of our polar equation. So let's take a look at example 5 over here. So they are saying the graph of the polar equation r equals 2 will consist of all points that are 2 units from the pole, right? So if you think about the pole again as your origin, then all the points that are 2 units away from our pole are going to satisfy the equation r equals 2, right? So you can see we are shading that entire second circle over here for our graph for r equals 2. Now, how do we convert this into a rectangular form? So they're basically saying this graph is a circle which is centered at the origin and that has a radius of 2. And if you remember your equations of circles from your college algebra course, then you can actually just use this equation right over here, r squared equals x squared plus y squared, where r represents the radius of your circle, right? So they're telling us r equals 2. So if we go ahead and square both sides, that will give you r squared equals 2 squared. So you end up getting, you can replace the r squared with x squared plus y squared, and then you have your 2 squared over here if you wanted to take this a step further, you could get x squared plus y squared equals 2 squared is 4. And this would also be your rectangular equation. So that's your circle centered at 0, 0 with a radius of 2. And that would end up giving you the same exact graph for the rectangular form as you did for the polar form. Okay? Now how about something like this? So we are given the polar equation theta equals pi over 3. So just to show you, pi over 3 is this angle right here. So if you just go ahead and extend this entire line, which goes from 4 pi over 3 all the way to pi over 3, this line, all of the points on this line are going to have the angle pi over 3. So that's why they're coming up with this line over here for. So they're saying the graph of the polar equation theta equals pi over 3 consists of all points on the line that make an angle of pi over 3 with your polar axis. And remember that positive x-axis is your polar axis. And they're saying to convert this to the rectangular form, we need to use that tangent theta equals y over x. So if theta is pi over 3, so these points right over here, when you divide sine by cosine, that cleans up into tangent of theta equals square root of 3, and then replace that tangent of theta with y over x using this relationship. That should be 3, and then multiply both sides by x, cancels out on the left hand side, and you end up getting square root of 3 times x as your rectangular equation. So that's how they came up with it, and that will again represent the same line over here. So again, you would get the same equation or same graph from the polar form as you do with the rectangular form. Okay? Alright, let's look at a different version now. So here they're saying if the graph of the polar equation r equals secant theta is not evident by inspection, because, you know, I mean, just by looking at r equals secant theta, how do you know what that graph is going to look like? So they are saying for equations like these, it is better to convert them to rectangular form by using this relationship right over here, r cosine theta equals x. Now think about this. This is r equals secant theta right now. But we know secant theta is the same thing as 1 over cosine theta. So if I multiply both sides by cosine theta, this will cancel out on the right hand side, leaving me behind with 1, and you end up with r times cosine theta, and we know r times cosine theta is going to become x. So you end up getting x equals 1, which is going to be this vertical line which passes through the x-axis at positive 1. And this is how you know what the graph of r equals secant theta is going to be, by converting it into the rectangular form. Okay, so 3 different examples just to show you how with each example your process is going to be different. Now going from rectangular to polar is not that hard, as you saw in this example right over here. But when you are going from polar to rectangular, you can see in each of these 3 examples we had to use a different approach. So let's go ahead and take a look at our problems over here. So again, they're saying describe each graph for the polar equation and then find the corresponding rectangular equation. So let's start with our first one, r equals 7. So r equals 7 basically is telling us that you have a distance of 7 from the pole, right? So if you have a distance of 7, and you know what, I think I am going to rewrite these numbers to accommodate that 7. So how about we make this last circle 7 units from our pole, from our origin. So when you are looking at its graph, this one here, will be, let me see if I can get this without making it too messy. It's going to be all the points that fall on this circle, which is going to be 7 units from our pole. And you can basically think of this as a circle centered at the origin, right? That has a radius of 7. So a circle centered at the origin that has a radius of 7, so we can use the relationship r equals 7. So if I do r square, I will do 7 square on the other side, and then I am replacing r squared with x squared plus y squared, and that 7 square will again end up becoming x squared plus y squared equals 49. So this is going to be our rectangular form. And here, the conversion that happened from here to here, we're basically defining r squared as x squared plus y squared. So instead of r squared, you can replace it with x squared plus y squared, and that's how we converted from the polar equation into a rectangular equation. Okay. So the other way to describe this would be all points 7 units from the pole. And of course that would be the same graph for both our polar form and rectangular form. Okay, so that's going to be our part A. Now let's look at part B over here. So we are given theta equals pi over 4. So again, you should know pi over 4 is your 45-degree angle. So that's going to be this line now, 45-degree angle. So it'll basically go from that 45-degree angle to that 225-degree angle. So let me see if I can go ahead and draw this graph. So 45-degree angle, of course, we know is halfway between this quadrant, and then continue halfway between quadrant 3. Okay, so basically that means you are looking at all the points that are on the line, which makes an angle of pi over 4 with your polar axis. Okay, so all points on the line that makes an angle of pi over 4 with the polar axis and passes through the pole. Here we go, and passes through the pole. Now again, remember the pole is basically the origin. So that's what this graph will end up looking like. Now when we are trying to convert this into the rectangular form, we of course need to think about tangent theta. What do you have tangent theta? So tangent of pi over 4, and again if it helps, look at the unit circle. So at pi over 4, when I divide sine by cosine, you will see I'm dividing the same number by itself, so I will actually end up getting tangent theta as a value of 1, right? So tangent theta will be 1. So if you have tangent theta as y over x, and tangent theta over here is your basically tangent of pi over 4, and again tangent of pi over 4 comes out to be 1. Let's get rid of this guy for now. And you get y over x equals 1. Basically go ahead and multiply both sides by that x, and you end up getting let's see, from here, you end up getting x equals y, or you can basically say y equals x. So this is basically a line that has a slope of 1 and passes through the origin, right? So this is going to be our rectangular form, which will also be the same graph as this line, which was at an angle of pi over 4 with your polar axis. Okay, so this is how we would convert it from the polar form to the rectangular form by using this idea of tangent of theta equals y over x, and then replace the value of tangent of theta that you got at that angle of pi over 4, which came out to be 1, multiply both sides by x, and you got the equation y equals x. Okay, now let's go ahead and take a look at our part C over here. Okay, so part C is given to us as r equals 6 times sine of theta. Okay, so this time when they are giving you 6 times sine of theta, it is definitely not going to be easy to visualize what this graph might come out looking like. Now, like I said, each of these problems, when you're converting from polar to rectangular, can take a little bit of work, so it may be a little bit of trial and error that is involved. So what we're going to do is we're still going to use that idea of r square on both sides, but basically instead of squaring the right hand side, r square basically means r times r. So I'm basically, in a way, you can think about it as multiplying both sides by r. So if you want, you already had that original r and we're just multiplying it by another r, and to maintain that balance we are multiplying by r on the right hand side. So this will end up giving you r square on the left, 6 times r times sine theta. But the reason we did that, the reason we brought that extra r, was because this thing here, r times sine of theta, we know we can write that as y, and then r square, we can write that as x square plus y square using this transformation here, right? R square equals x square plus y square. So we're bringing that idea to replace our r and r sine theta with the x and y variable. So you end up getting x square plus y square equals 6 times y. We'll go ahead and bring that 6y over to the left hand side, and you end up getting x square plus y square minus 6y equals 0. And then at this point, we will need to use completing the square, because we still don't know what this graph is going to come out to be if we leave it in this form. So for completing the square, that x square part will stay as it is. We're not making any changes. But then here with the y square, by completing the square, you take the middle term, which is that 6 divided by 2, and square the answer. So 6 divided by 2, of course, is 3. 3 squared gives you 9. So we are going to have y squared minus 6y, and then this 9, we are going to go ahead and add it to both sides of our equation, because of course we want to maintain the balance of our equation. And now this becomes a perfect square trinomial that you can factor, and this will factor into y minus, and you can see we use 3 squared to get to this 9 over here. So that 3 squared, that number 3, is what this guy factors into, and you end up getting the equation x squared plus the quantity y minus 3 squared equals 9. So again, we just, like I said, factored the y squared minus 6y plus 9 into y minus 3 quantity squared. And this here now is your rectangular form for this equation, r equals 6 sine theta. So this is your rectangular form. And this is going to be a circle which is centered at, you can see this x squared tells us that that number for the x coordinate is going to be at 0, and the y minus 3 actually tells us 3 is the positive number here, and so our y value is going to be at 3. So the center for our circle is going to be at 0, 3, and the radius is going to come from the right hand side, and that's going to be r squared, which is going to be r equals 3. So that's a radius of 3 units. Now again, guys, this is something you should remember from college algebra, where the general form of your circle is x minus h squared plus y minus k squared equals r squared, and this is where the center of your circle is at h comma k, which is of course coming from these values here. So if you have a minus sign here, that means h, k are positive, and then your radius is going to be the square root of the right hand side, so your radius is just the number r. So instead of r squared, you just look at the square root of that value, which gives you the radius. So that's why we took the square root of number 9, which gave you a radius of 3. And so now start with the center. Your center is at 0, 3. So again, I'm actually going to have to change these numbers over here to accommodate all of our values. So how about we change these circles to 2, 4, and 6, which means our center of 0, 3, if this is 2, 4, and 6, our center is going to be at 0, 3, and this is, of course, we are pretending this is our x and this is our y-axis here, and then it has a radius of 3. So you go up 3 units, you go, I guess halfway here would be 1, so that go 3 units here, and then of course we would need to go 3 units left and 3 units right to get our complete circle, and it should end up looking something like this. Just doing our best to go 3 units to the right and left. Not a very good job here, but let me try again. Maybe something like this. It doesn't have to be perfect, as long as you get an idea. So this is actually what the graph of r equals 6 sine theta is also going to come out looking like. But yeah, it can be hard to identify what that graph ends up looking like when you just look at that equation. So again, this was our center at 0, 3, and this had a radius of 3 units. Okay, now remember, this r value is not the same r value we are looking at here in our polar coordinates. We just use r as the variable for radius, but this r is not the same r over here. Unless you can show that it is the same r value, and I'll leave that for you guys to verify. Alrighty, so this is how we went from the polar form to a rectangular form. So again, like I said, for each of these parts, A, B, and C, you can see each one of them had a different approach. So that is something you are going to have to practice and see how to come up with your rectangular equations. Alrighty, so this was our example for 5, and I believe this was our last example over here. So again, guys, look through the handout, look through the video, and let me know if you have any questions. So be careful, be safe, and I will see you in class next time. Alright guys, take care, have a good day, bye bye.